Hello everyone. In this video, we will learn how we can do normalization in third normal form, or in short 3NF. What is third normal form? A relation is in third normal form, then it should be, the first condition is that it should be in second normal form and it shouldn't contain any transitive partial dependency. We have already learned how a relation can be converted to first normal form and how it can be converted to second normal form. First normal form condition is that there shouldn't be any multi-valued attributes. Second normal form condition is that there shouldn't be any partial dependency. The third normal form condition is that the relation should be there in second normal form. Also, there shouldn't be any transitive partial dependency. Basically, these normal forms are used to reduce data duplication, and also we can achieve data integrity by means of normalization. So basically this third normal form, it meets all the requirements of the second normal form, and we have to remove columns that are not dependent upon the primary key. So if there is no transitive dependency for non-primary attributes, then the relation is said to be in third normal form. So there shouldn't be any transitive dependency for non-primary attributes. So if we have a non-trivial functional dependency like this, if y is depending on x, then in third normal form, the condition is that this x should be a super key. So if y is depending on x, then x should be a super key, and y is a primary attribute, and each element of this y should be some candidate key. So these are the conditions for third normal form. So let us see one example here. We have a table relation in which we have the primary key attribute as student ID and the remaining attribute non-primary attributes as student name, city and zip. So in this relation, we know that we can identify city from student ID. Also, we can determine city by means of zip, also zip code. So basically neither the city or this zip is a primary attribute, or nor it is a super key. So if you want to make this relation into a third normal form, then what we can do is we can decompose this relation into two relations. That is, one relation is student ID, then student name and zip. Another relation with zip code, zip and city. So basically what is happening is, in this one actually student ID is the key attribute, and you can find student name from student ID, even you can find city from student ID. Also the thing is, by knowing zip also you can find city. That means it is depending on this non-primary attribute here. That is why there is a transitive dependency. So here we have separated this relation into two relations. One is student detail. In here you can see that student name as well as zip is depending upon student ID. Even the city is depending upon zip, which is the primary key. Here zip student ID is the primary key in the relation student detail, and zip is the primary key in the relation zip code. So there is no transitive dependency in this case. Let us see an example and we will see how we can decompose a relation into third normal form. So in this example, the student relation is given. We have three attributes. One is roll number, then game and fee structure. So here the dependency, the functional dependencies are given like this. You can have, game can be determined by roll number. Even fee structure can be determined by roll number. But even the fee structure can be determined by knowing the game also. The name of the game also you can determine the fee structure. So suppose you are taking this roll number closure. A roll number closure, if you are taking, you will be getting roll number itself, because we have the functional dependency like this. Roll number, by knowing roll number you can find game. By knowing roll number you can get fee structure. But by knowing game you can get fee structure again. So here there is a transitive dependency if you see. So roll number closure, so we need to find which are the primary or super key attributes of this one. So here when we take the closure of this roll number, so roll number itself will be a set, will be there in the set. So first will be roll number, then roll number is determining game. So game also comes in that one. Even roll number is determining fee structure. So all those things will come in roll number closure. So roll number, game and fee structure are part of roll number closure, or roll number plus we say. So the closure of roll number, you are getting the attributes roll number, game and fee structure, means all these attributes in this relation can be found by taking the closure of roll number. That means that roll number is a primary key, because by knowing this one we can find all the remaining attributes, or you can say it as a super key also. So here this relation, the student relation, is in first normal form because there are no multi-valued attributes present in this relation. So that is in first normal form. Also, if you observe this one, you can see that this relation is in second normal form, because you know the key attribute is roll number, and what are the non-key attributes of this relation? One is game, another one is fee structure. So as you see that, if you can see all the non-key attributes are depending on the roll number, means by knowing the roll number you can find game, by knowing the roll number you can get the fee structure. That means that fee structure is depending on roll number, even game is depending on roll number. So all non-key attributes are depending on the primary key attribute. So hence this is a relation is in second normal form, because all these non-key attributes are fully depending on the primary key. What is our primary key? Primary key is roll number. So all non-primary key attributes are fully depending on the primary key. Hence this is in second normal form. But this relation is not in third normal form, because there is a transitive dependency. If you see here, we can determine game from roll number, we can determine fee structure from roll number. By knowing this, even we can determine fee structure from game. So you can see that this roll number, there is a transitive dependency here, because fee structure has a transitive dependency on roll number via game, because you can determine game by roll number, and by knowing the game you can find fee structure. So there is a transitive dependency. So if you can determine B from A and C from B, and that means that C can be determined from A, that is the transitive dependency. So here game can be determined from roll number, and fee structure can be determined by knowing game. That means that even we can find fee structure by knowing the roll number. So there is a transitive dependency. So fee structure is a transitive dependency, has a transitive dependency on roll number via game. So this is not in third normal form, because third normal form rule states that the relation should be in second normal form and there shouldn't be any transitive dependency. But in this particular relation, you can see there is a transitive dependency. So how we can convert this into third normal form, we'll see. Also, because of this relation is not normalized one, so you can see there are anomalies present in this relation. So what are the anomalies present? So here this one, insertion anomaly. Suppose I want to insert a new game into this relation. So it is not possible, because either if a student is not enrolling into that game, you can't insert that into this relation. So that is called insertion anomaly. So insertion anomaly is present in this relation. Another one is deletion anomaly. Suppose I'm deleting this roll number 7 from this relation, the whole tuple will get deleted, and the information about the game 10 is also gets deleted along with this tuple. So the information about the game tennis is gone. So there is a deletion anomaly there. Then we have updation anomaly also present in this one. Suppose I am changing the fee structure of this basketball, then I need to change it in several other tuples also. So that is the updation anomaly. See, all these anomalies are present in this relation. So we need to normalize this relation, and we have to put it in third normal form. How we can make this relation into third normal form? Because we already know that it is in second normal form. Second normal form means already it is in first normal form. Now we need to convert this one into third normal form. So what we have to do is we have to decompose the relation. How we will decompose the relation? Now we have a transitive, suppose we have a transitive dependency like this, means that y is having a dependency on x, so is a transitive dependency, then what we can do is we have to divide the relation. Suppose R is a relation and there is a transitive dependency like this, y is depending on x, then we can decompose the relation R into R1 and R2. How will you decompose it? That one is that R1 we can make it as x closure. What is x closure? If this is the transitive dependency, that is y is depending on x and this is the transitive dependency, and whatever attribute is on left hand side, that is this x, find the closure of that one, that you make the relation. So find the closure of left hand side and make the relation for that one. And the second relation you make for the right hand side closure. So find the closure of right hand side, the transitive dependency, and subtract that closure from the original relation, and whatever is remaining make the new relation. So R2 is R minus, R is our original relation, minus y plus. What is this y plus? In the transitive dependency, what is on the right hand side, the closure of that attribute will give you y plus. So subtract that one from the original relation, and whatever is left out, that will be your new relation R2. So this is how we'll be decomposing the relation R into R1 and R2. So what is our transitive dependency in this particular relation? We have a transitive dependency like this. Fee structure is depending on game. So through this, fee structure is depending on game, and as we know that game is already depending on roll number. So what does it implies? It means that fee structure can be determined by knowing roll number. So there is a transitive dependency present here. So fee structure depending on game, here this is a transitive dependency, and left hand side we name it as x and right hand side is y. So x to y we'll be making, and for making relation R1, what we do, we will be taking the closure of x. So this is our transitive dependency. Fee structure is depending on game, and what is this x? X is game and y is fee structure. And what will be, how will we be making the relation R1? By taking the closure of x. So x is game here, so closure of game. So game closure, what you will be getting, we'll go to the original relation and see. When we take the closure of game, the first element will be game itself, and we know that by knowing game we can determine fee structure. That means game closure will be, the elements will be game as well as fee structure. So game closure, you are getting the elements game and fee structure. So in the first closure, that is x plus, that is this game closure, you are getting the attributes game and fee structure. So what will be our first relation? First relation is this x plus, that is nothing but game plus. So you are getting the attributes game and fee structure. So the first relation R1 will be having the column game and fee structure. What about the second relation R2? R2, you have to take the original relation minus y plus. So what is this y plus? Y is on the right hand side, that is fee structure here. We will go back and see what is the relation between fee structure. So when you take fee structure is not depending on anything. As you can see on left hand side, there is no fee structure. So when you take the fee structure closure, only the element present will be fee structure only. So fee structure closure is fee structure. So when you take this closure fee structure and subtract it from the original relation, this is our original relation. If we remove this fee structure, what are the attributes remaining? Roll number and game. So R minus y plus, you will be getting roll number and game only. So here in this case, when you take fee structure closure, what you are getting? Fee structure closure student, that is the original relation, minus fee structure closure. Fee structure closure, the set is fee structure only, and all the remaining three attributes you subtract fee structure, you are getting roll number and game as the remaining attributes. So what will be our relation R2? R2 will be roll number and game. So now we have decomposed this relation R into R1 and R2, where R1 consists of attributes game and fee structure, and R2 consists of attributes roll number and game. So here we can see R1 consists of game and fee structure, and R2 consists of roll number and game. So Now when you observe this table, you can see that we can get rid of all the anomalies present here. Now for insertion anomaly, if I want to insert a new game, I can add it here. I can add it here in this table. I can add new game into this table. If I am changing the fee structure here, there is updation anomaly is removed, insertion anomaly is removed, and deletion anomaly. Suppose I am deleting this roll number 1 data from here, which is the game basketball information still remains in the other relation. So we have eliminated all the anomalies, updation anomaly, insertion anomaly, and deletion anomaly by normalizing the relation. So we were having a relation, and what we have done is we have decomposed this relation. This relation is already in second normal form, and this relation is not in third normal form. Why? Because there is a transitive dependency present in this relation. So for getting rid of the transitive dependency, what we have done is we have decomposed this relation into two. And how we have decomposed that relation is by means of this rule, and we have got two relations like this, and by this two relations R1 and R2 are in third normal form, because there is no transitive dependency present in this relation. So this is how we decompose a relation, or we do normalization of database in third normal form. Hope you understood how to convert a relation into, how to normalize a relation into third normal form. Thanks for watching. Thank you all. Hope you understood. Thanks.